Hi, this is Hilal. In this video on mathematical economics series, we will solve a general optimization problem. The question is, let maximize the utility which is equal to log x1 plus log x2, where x1 and x2 are the two goods subject to the budget constraint. M is the total income, and budget constraint is known as P subscript x1 times x1, that is price of x1 times the quantity of x1 plus price of x2 times the quantity of x2. We have to find the optimal bundle uh, for this very problem. So we will use the Lagrange's method of finding the optimal bundle here. First of all, what will we do in this situational question? We will first of all form the Lagrange's function. So Lagrange's function is basically formed by first we take this constant function and set it equal to 0. So I will set it equal to 0. So this will become m minus p x1 times x1 plus p x2 times x2 is equal to 0. After that, we set this constant, we multiply this constant by the lambda. So I will multiply it by lambda. This will become minus p x1 times x1 plus p x2 times x2 is equal to 0. Now we will form the Lagrange's function. Lagrange's function is formed by adding the objective function. This is called this utility function in the optimization problem. We also call it the objective function. We add the objective function and the resulting constant function. That is to form the Lagrange's function. That is we denote this by L. Let us say we write this function log of x1 plus log of x2, and to this we add this the resulting constant function, which is formed by setting the constant first equal to 0 and after that multiplying it by lambda. So this will become m minus p x1 times x1 plus p x2 times x2. Okay. To get the optimal values of x1 and x2, what will we do? We will partially differentiate this Lagrange's function with respect to x1, x2 and lambda and solve them simultaneously, and also set them equal to 0. So first we take the first derivative L. X means partially differentiating this Lagrange's function with respect to x1. So here it will become 1 divided by x, because log of x, its derivative is 1 by x. Plus, since here is no x1 involved, so it is 0 here. Here we can see x1 is also only in this very term, so here the derivative of x1 is 1. Now what we will get here, we will get here minus lambda times px1 minus lambda times px1 and set it equal to 0. Similarly, we will differentiate with respect to x2. So here the derivative of this x1 will be 0, because we are differentiating with respect to x2. Here the derivative of log of x2 is 1 divided by x2. Similarly, seeing here is our x2, the derivative of x2 is 1, so lambda times, actually it is here minus, so this will become minus lambda p x2 and also set it equal to 0. Or here we can also write it as 1 divided by x1 is equal to lambda times p x1. Here also 1 divided by x2 is equal to lambda times p x2. Okay. Now similarly we will differentiate with respect to lambda. Since no lambda is involved in those terms, so the derivative will be 0. Here the derivative of lambda is 1, so we will get this very term as the derivative of the Lagrange function with respect to lambda. That is m minus p x1 times x1 minus p x2 times x2. Okay, and set it also equal to 0. Let this be equation first, let this be equation second, and let this be equation third. Okay. Now we will divide equation 1 by equation second. That is 1 divided by 2 will give us, this is 1 divided by x1 whole divided by 1 divided by x2 is equal to lambda p x1 divided by lambda p x2. Lambda gets cancelled. Here it will become this will become x2 divided by x1, which is equal to p x1 divided by p x2 here, okay, or which implies our x2 is equal to, transposing this on this side, so p x1 divided by p x2 times x1. So we will put the value of x2 is equal to this in equation third. So I will put this value in third. So what will we get? We will get m is equal to, that is m minus p x1 times x1 minus p x2 times the value of x2 is this p x1 divided by p x2 times x1 is, which is equal to 0 here, okay. Now cancelling this px2 and this px2, what we get here, that is m minus p x1 times x1 minus p x1 times x1 is equal to 0. Now further solving this will become m minus twice p x1 x1, because these two terms are same, we can subtract to them, which is equal to 0, or our 2 p x1 times x1 is equal to m, or our x1 is equal to m divided by twice p x1. So the optimal value of x1 is this m divided by twice p x1, that is the total income divided by 2 times the price of x1. Similarly, the x2 will get, if we put x1 in the third equation, we will get x2 is equal to m divided by twice p x2. So these are the optimal bundles which we can buy to optimize our utility, okay. I hope I make myself clear. First we were given a utility function with the budget constraint here, okay. We were told to optimize this or find the equilibrium level of x1 and x2. So how we solved this? First of all, we took this budget constraint and set that equal to 0. After that, we multiplied this budget constraint with lambda. After that, we formed the Lagrange function by taking the objective function and adding to this objective function the resulting constraint function. So this became our Lagrange function. This is our Lagrange function, okay. After that, we partially differentiated this Lagrange function with respect to x1, x2 and lambda, and set them equal to 0 simultaneously, as we have seen here. After that, we easily got the values of x1 and x2, okay. Thank you.